Hello students.
Today we'll learn the next concept, that is integration by parts. When will you use the integration by parts? So integration by parts we use when the integrand is a product of two different types of functions. That is, suppose if you have x square and e power x, it is just like the product rule. Actually, the integration by parts is derived from the product rule of differentiation. The product rule of differentiation only this is derived. So, suppose if you have product of two different types of functions, you have x square is an algebraic function, e power x exponential function. So, whenever you have to integrate like this, you use the integration by parts. Or single logarithmic function, sometimes you have to integrate log x or log 2x. Directly you don't have a formula, so you use integration by parts. Or sometimes you have inverse functions, sine inverse x, how to integrate sine inverse x. So we use integration by parts. Or a function which is not integrable directly. Directly there is no formula, we use the integration by parts. So it is derived from the formula of derivative of product of two functions. So you know the product rule in differentiation. What is the product rule in differentiation? uv dash is uv dash plus vu dash, isn't it? So that is u v du plus u dv. So you take u dv here, duv minus, bring the v du here, duv minus v du is u dv. Now integrate both the sides. You get integration of u dv is integration of duv. See, you know integration of dx is x. So integration of duv is uv itself. Integration of duv is uv minus, you are integrating every term, this term, this term and this term. So finally we get integration by parts. This is a formula. Integration of u dv is u into v minus v du. This is the integration by parts formula. Now there are two functions here, x square e power x. Which one will you take as u? One function take it as u, the other function take it as dv. It is integration by parts. We are dividing this question or this integrand into two parts. Okay, one you are taking it as u, the other one you are going to take it as dv. Now, which one you are going to take it as u? The choice of u is very important. Choose the wrong function as u, then the integral you may not be able to integrate after a certain stage. So the choice of u is very important. Which function to choose as u is very important. So which function to choose as u, you can follow a rule or a hierarchy like this. I late is first inverse. I stands for inverse. If there is an inverse function in the question, take that as u. For choosing u, you can follow this. L stands for log. If there is a logarithmic function there, you can choose that as u. Algebra, A is algebraic function and T stands for trigonometry and E stands for exponential. For example, this sum that I gave you, x square into e power x. X square is algebraic function, e power x is, so which one will you take it as u here? Which comes first? Is algebra or exponential? Which comes first in this order? Algebra comes first, isn't it? This is the order. So take u as x square. Take u as x square. The remaining part take it as dv. So dv is e power x dx. Got it? So it's very important which one you choose as u. So you can follow this rules. Suppose if you have x square and log x. In that case, you take u as, because log comes first, log comes before algebraic function. So you should take u as log x and the remaining you take it as dv. If inverse comes, you have to take u as inverse. Suppose if you have x into, sine inverse x. So you take u as sine inverse x and remaining as dv. The proper choice of u is very important. The success of this method depends on the proper choice of u. If the integrand contains non-integrable functions, suppose if you have only sine inverse x, there is nothing else, you take u as sine inverse x. Or if you have only log x, then you take u as log x. Okay, if integrand contains any non-integrable functions directly from the formula like log x, tan inverse x, so we take these functions as u and the other as dv. Suppose if the integrand contains both integrable, take u as x power n. For other cases, the choice of u is ours. Bernoulli's formula for integration by parts is very important formula. Bernoulli's formula for integration by parts. So if u and v are functions of x, then the Bernoulli's rule is integration of u dv is uv, alternate, first plus then minus then plus, like that, uv minus u dash v1. What is the next one? Plus u double dash v2. What will be the next one? Minus u triple dash v3. It goes like this. What is this u dash null? U and v are the functions given in the question. U dash is differentiation of u. v1 is integration of v. So one function you keep differentiating, the other function you have to integrate. The u, whatever function you have chosen as u, you keep differentiating. The other function you keep integrating. Now Bernoulli's formula, when will you use Bernoulli's formula? It is very useful when your u is, you're choosing the function u and v. No? If u is x power n, if u is x power n, then use Bernoulli's formula. It will be very easy if you use Bernoulli's formula if u is x power n and your n is more than 1, suppose 2, 3, like that, you can always use Bernoulli's formula. It will be very useful, very easy if you use Bernoulli's formula when u is x power n. So now with these two, we'll move on to the exercise 11.7. The first question is integrate 9x e power 3x dx. Write the constant outside the integration, 9x e power 3x dx. Now I will do this sum using three different methods. Now one is Bernoulli's, one is integration by parts, it's again integration by parts but in a different way. Okay, you choose which is better. So first method, I am going to use integration by parts. This method I am going to use u dv. Integration of u dv is uv minus v du. This is the method I am going to use. So you have to choose one function as u. So as I told you, the rule, you can follow this rule to choose this hierarchy you can follow. So you have x is the algebraic function and e power 3x is the exponential function. So which one is coming first? Algebra comes first, exponential comes later. So you can choose u as x. Are you following? And dv, you take it as e power 3x with the dx you write. Okay, u as x and dv as e power 3x dx. Now you have to differentiate here. Actually, du, u is x, du by dx is 1. Isn't the differentiation of x is 1? So I can write du as dx. So I am going to write du as dx because du by dx is 1. So you differentiate here, integrate here. Integration of dv is v. And integration of e power 3x is e power 3x, x coefficient is 3, divide by 3. Now you use the integration by parts, that is integral of u dv is u into v. I put this arrow mark because u into v You're not using this u into v minus v du. Okay, so what is u? X v, this is v, e power 3x by 3 minus v minus integral sign you have to put e power 3x by 3 and du is dx. So the integration by parts is also called as partial integration because this is not giving you the final integral answer. Final integrated answer. Again you have to integrate. Okay, so integration by parts in some countries it is also called as partial integration because again you have to integrate. It is not fully integrated. So again you have to integrate. So x by 3 e power 3x minus 1 by 3 integrate e power 3x. Integrate e power 3x, what do you get now? Again e power 3x by 3. E power 3x, 1 by 3 I have taken out, by 3. So that means it is x by 3 e power 3x minus e power 3x by 9. Remember there was one 9 outside, I didn't even take that. So integration of 9x e power 3x dx is, put one the 9 also, x by 3 e power 3x minus e power 3x by 9, put the constant c. You can see that e power 3x is common, right? So take out that e power 3x and 3 is also common, take it out. E power 3x, I am taking it out. So here you get x minus 1 by 3. Isn't it? That 9, I have taken out 3 outside. So that is 3 e power 3x, 3x minus 1 by 3 plus c. This 3 and this 3 you can cancel. So the final answer is e power 3x into 3x minus 1. So this is one method of doing it. Now what is the second method? Method 2, the same sum, I will teach you everything. So you can choose. Method 2 is, I am going to use the Bernoulli's formula. Now when will you use the Bernoulli's formula? When your u is, which is u here, we already chosen u. When u is x power n, so u is x only, right? X power 1. So we can use Bernoulli's formula. When u is x, you can always use Bernoulli's formula. When u is x power n, better use Bernoulli's formula. N is 1 here, that's it. And your dv, just write it up, e power 3x. Now you keep differentiating here. So u dash, differentiation of x is 1. Integrate here. What is the integration of dv? V. That is e power 3x by 3. What is integration of this again? V1. Keep integrating this. So what will you get? E power 3x by 3. Already one 3 is there, so it will become 9. So you can stop here because when you get a constant, constant means independent of x, there is no x here, you can stop differentiating. Okay, till you get a constant, you have to differentiate. So here it is a constant, you can just stop. So what is the Bernoulli's formula? The Bernoulli's formula is integration of u dv is uv minus u dash v1 plus u double dash v2. It goes like this. We need only these two. This is plus, next one is minus, remember that. So integral of, the question is x e power 3x. E power 3x, you can put the 9 outside, or 9 also, so you can keep the 9 outside, and then you write uv, multiply u into v, straight away multiply x e power 3x by 3 minus of, okay, minus, multiply again this one, so put the minus sign, multiply, so you will get e power 3x by 9. That's all. You can just close this. That's it. You can take out 9 e power 3x take it out, or you can by 3 also you take it out. So you get here x minus 1 by 3. So this get cancelled. So you get 3 e power 3x into 3x minus 1 by 3. So that's the answer. The same answer we got. See? Now the other method, you just don't take it as u and dv. So there is a question is integral of 9 x into e power 3x dx. Choose your first function as, the first function again the same hierarchy. So we are going to choose the first function as x. First function is x. The second function I am going to take it as e power 3x. So the rule is, write the first function as it is, integrate the second function, minus, differentiate, put the integral sign, differentiate the first function, integrate the second function. It looks very complicated, but it is very easy. I'll tell you. So what do you do now? There's one 9 here. 9, are you following? X e power 3x dx is, put the 9 outside. First function as it is. First function as it is. So I'm going to write the function as it is. Second function, integrate. So what do you get? E power 3x by 3 minus, put the integral sign, differentiate the first function, so it will become 1. Now the same thing write again. This thing, integrate the second function. No, same thing you copy it here. So the answer, the final answer is 9 x e power 3x by 3 minus, integrate this. So you'll get e power 3x by, already one 3 is there, this 3 will give you 9. So same thing. So 9 e power 3x by 3, take it out. So you will get x minus 1 by 3. Right? So that is equal to 3 e power 3x, 3x minus 1 by 3. So that's the answer. So this is also another method of doing it. Same, this is also called as integration by parts. So here we are not writing it as u and dv. We are writing it as a first function, second function. So write the first function, integrate the second function, minus integral of, differentiate the first function and integrate the second function. So these are the 3 methods. You can choose any one of these methods. Now we'll move on to the second sum. Integral x into sine 3x dx. Which one will use now? U. I'm not taking it as u, and you said the last method, right? So I'm going to use I as the first function as x, or you can write, instead of writing I, you can write f of x. That also you can write. Instead of writing 1 and 2, the second function you're going to take it as sine 3x, or you can write this as f of x. First function as x, the second function you can take it as sine 3x. So what we should do? Integration of x into sine 3x dx is, write the first function as it is, integrate the second function, minus, differentiate the first function, integrate the second function. Shall we do straight away now? First function as it is. Second function, integrate. What is the integration of this function? Minus cos 3x. So integration of sine 3x is minus cos 3x. This coefficient of x is 3. Divide by 3. Minus. Put the integral sign again. The first step itself we will not get the solution. You have to integrate again. Remember that always. I dash. Differentiate this. Differentiation of x is 1. Integration of, right? Same thing, right again. Minus cos 3x by 3 dx. So one more integration you have to do. So it is equal to minus x by 3 cos 3x minus into minus plus 1 by 3 integration of cos 3x dx. Okay, minus into minus plus. So that is equal to minus x by 3 cos 3x. Now integrate cos 3x. What is integration of cos 3x? Sin 3x. Sin 3x by 3. The coefficient of x is 3. You have to divide by 3. So that's it. So the answer is minus x by 3 cos 3x plus sin 3x by 9. That's it. The next one, third question, 25, take a constant x e power minus 5x dx. So you have algebra and exponential. So your first function is x. The second function is e power minus 5x. Correct? First function is x, second function is e power minus 5x. So you have 25 integral x to the power e power minus 5x dx is 25 is a constant, write out. Then write the first function as it is. Second function integrate. Directly you can integrate. So this e power minus 5x by minus 5. Then minus, put the integral sign. Differentiate the first function. It is 1. Second function, you are integrate this function. Integration of the second. Already we are integrated here. So write the same thing here. Okay, integration of the second function. See, the formula is first function as it is, integration of the second function minus differentiation of the first function, integration of the second function. So you are copying the same thing here. Now into dx. So that is equal to 25 is completely outside, minus x by 5 e power minus 5x minus into minus plus 1 by 5. Integrate again, e power minus 5x by minus 5. Okay, this minus 5 is already there. So what do you get now? 25 minus x by 5 e power minus 5x minus 1 by 25 e power minus 5x. So you can take out the 25. E power minus 5x, you can take it out, and also by 5 you can take it out. Okay, so what do you get here? Minus x. Even minus you can take it out. Minus is common, take it out. So you will get, so I have taken e power minus 5x by 5 minus also. So become x plus 1 by 5. 1 5 I have taken out. So that means I will get the answer minus 25 e power minus 5x by 5, and here 5x plus 1 by 5 plus c. So this 5 and 5, 25 get cancelled. So the final answer is minus e power minus 5x, 5x plus 1 plus c. So that's the answer. The fourth one, integration of x into secant x tan x dx. Remember that order to choose u. So you have algebra, trigonometry. Again algebra comes first. Algebra comes before trigonometry. So put first function as x. The second function take it as secant x tan x. So the formula is first function as it is. So integration of first and second function is first function as it is, integration of the second function minus first function's differentiation and integration of the second function. So let us write the first function as it is. What is the integration of secant x tan x? Secant x minus differentiate the first function. So it will become 1. So put the integral sign. Okay. This one you copy it here. Secant x is just same thing you copy here. So now that is equal to integration of secant x is log, put the modulus sign, secant x plus tan x. Please learn the formula. It's a formula, integral formula. Log secant x plus tan x. Put one C, that's it.